Hey everybody, and welcome back to another video in this series. So in today's video, what I am going to be doing is this is going to be primarily an update video from the previous leg IK video, because I want to do this update as I found more information on how to better do foot placements without having to migrate in the control rig, as you see that we have here in the third person, sample project that we're working on. We are a little GASP from scratch project. So I want to give a huge shout out to another YouTuber called Hikari Azyure. I'm sorry if I butchered your name. I am trying to learn Japanese. But I will leave a link to his channel in my YouTube description for this video, just because I want people to actually go and check out his showcases, as he's doing some really cool stuff. And he also informed me about this. We had a pretty productive talk in the leg IK comments. So he is pretty much a godsend to me, and showed me this method, which I thought was phenomenal. And I doing research prior to him even telling me about this, I couldn't find anything regarding this node, but we're going to go over that in this video as a little update, so that way we can get rid of the control rig, and then we can modify it with the leg IK to actually appropriately do our foot placements. So what we're going to do is I am going to start by undoing this control rig, because like I said, we are not going to be utilizing it anymore now that I found a better node. So what we're going to do is we're going to move over the component local, and we're going to move over the leg IK. So what we're going to grab in the random space is, if you right click into the space and you look for foot placement, just like that, underneath skeletal controls, you will see this node called foot placement. When you grab it, it looks pretty similar to the offset root bone, as far as kind of what the component is and how it is experimental and whatnot. Because it is, as you can see right here, it is an experimental class. So one of the things that I've been briefly researching, I haven't had a chance to look over all of these settings. However, I can kind of guess what they do to a certain degree based on how we talked about the leg IK and other stuff that I've been researching. So basically, with the foot placement, this actually has, I'm pretty sure, C++ built-in coding. I'm pretty sure this is coming off the animation warping and whatnot, that will allow you to actually have proper foot placements on the slope, as well as do slope warping on your feet. So how when you go up ramps and whatnot, how the feet, even if you have this control rig, nodes set in your character anim blueprint, how you'll still notice that when you go up a ramp, that your character's feet does not warp properly to show an incline of the foot, or a decline of the foot, depending on how you stand, right? So with this actually does more calculations and whatnot within its node, whatever the C++ is to it, that will actually allow you to get the slope warping, and be able to account for that, as well as its own IK tracings, to be able to find the step or the slope, or whatever sort of like wherever the floor is, it'll find, right? So to show you how this is gonna work, I am going to put this and connect it here, and I'm going to show you why I'm specifically connecting it to here in just a moment. However, before we can actually utilize this foot placement node, we do need to call some parameters in here in order for it to work properly. So for the plant speed mode, this is one of the ones we want to go over to, because as you can see, when we hit the drop down, we have a graph and we have a manual. Well, we're going to want to set this similar to the other one. I believe it was offset root bone. Yeah, like offset root bone, where it has evaluation mode graph. We want to set this to graph, so that way whatever data or output it gets from the previous nodes that pass its data through here, we want to be able to get that graph data in order to warp our character's feet, so that way it gets the proper foot placement and also account for slopes. So, as you can see when we read over the plant speed mode, that the football speed evaluation mode, graph or manual, used to decide when the feet are locked. Graph mode uses the root motion attribute from the animations to calculate the joint speed. Manual mode uses a per foot curve representing the joint's foot. So the plant or the curve that they're talking about is stuff like within, I believe it would be within trace settings. I gotta double check where that's at. Either that or it is somewhere within here. It's probably in the pelvis. I think it's the pelvis. No, I don't know why I'm not seeing it anymore. So, but regardless, we have plant settings on how it does calculations on where to plant the feet. And then it has interpolation settings on how to best guess or guide the foot down to the floor and place it on the floor appropriately. So you have a lot of this stuff as too, where it's like we have separations, floor angles, linear stiffness, dampening, stuff like that. So like I said, I haven't had time to research all of these to be able to give y'all the best descriptions of it. So I will do a future video on this to go over this setting, as I wanted to just kind of get this update video out to show y'all this cool thing by Hikari. So then it also has its trace settings, where kind of how I showed you on the previous leg IK video on how it does a basic foot IK. This one does more like, I guess, complex tracings to be able to accurately find the floor and, account for slopings and stuff like that. So, we also have law threshold, which you talked about yesterday, and also it has the alpha, content that we spoke about, as well as the bias clamp. So these are pretty much going to be similar to how we have the leg IK set up. We're going to keep it at the default values, pretty basic, because we don't need to modify anything. However, now what we need to do is so once we change it to graphs, that way we can get the data that is passed through our anim graph into the foot placement, we need to look for our root bone. So this is actually pretty simple, because we need the inverse kinematics foot root bone. So you just go into here and then just, type in root, and it should be, right here, IK foot root. So you're gonna want to grab that, and then in the pelvis bone, all you're gonna do is you're gonna type in pelvis to grab that. It's very self-explanatory. All you're doing is like matching square peg to square hole kind of thing in here. So then the next place that we have to do it is right here at these leg definitions. So like how we have the leg IK set up and how we call the leg definitions in here, as you can see with the IK foot L and then the foot L for the forward kinematics, is we want to now grab those two IK measurements and throw them into here. So for our first one, they do have it in a bit of a different setup, where they have the forward kinematics first, then the inverse kinematics, but literally the same thing. All we're doing is we need to get the foot L for here. So just type in foot and get foot L. And then for the IK foot bone, we want the IK underscore foot underscore L. So just like that. However, now what we have to do, this was the speed curves that I was talking about. So this is earlier where the curves they're trying to get in order to like lock curve names like alpha, like the alpha numbers and stuff like that. But again, I'm not entirely fluent on this because I haven't been able to do too much research on this. However, like I said, I wanted to get this video out because I was quite excited about this. So with the ball bone, all we want to do here is we want to type in ball, and we want to get the left ball, which, if you don't understand what a ball bone is, think of a ball joint. So you'll hear that term like ball joint in real life anatomy. So like your elbow would be considered a ball joint. Your ankle, like where your foot is, would be considered a ball joint because of how it allows you to kind of rotate your foot or your arm around. Even I think your shoulder bone, like you probably have a shoulder ball bone joint because of how you're able to rotate around, like actual circular motions with like your arm or your elbow or your ankle for your foot, stuff like that. So then just like with the leg IK, where the number of bones they had set in there's 2, we're going to keep that 2 here as the default. And then everything else we're going to leave as done because we don't have a float curve or anything to call within any of these, so we don't need to make those modifications because the setup that we're doing is pretty much going to be enough for this. So now we want to go ahead and do the other foot, where we are going to call the foot R here, so foot underscore R. And then for the inverse kinematic foot bone, we're going to click into it and look for IK_foot R, just like that. And then for the ball, just like with the left one, we're going to look for ball R for the right ball joint. So now that we got that, there's nothing. We're going to leave the plant settings, interpolation settings, and trace settings as the default. So until I get a better update video out where maybe I found better modifications, we're going to leave them as default. So once we have that, let's go ahead and we're going to connect our output pose from the component to local to output, and we're going to compile and save. And then when we actually play, when we start going up slopes, look at the foot placement on that. As you can see with how it's rotating pretty nicely as far as foot placements. I know there is a little bit of jankiness because of how we have, you know, the setups involved with, you know, basic legging setups. We don't have like the full steering and other stuff that comes in with the, you know, motion matching yet, because we still have yet to set those up. I'm still working on doing a little bit of research with that, so that's why I wanted to use this as a buffer video. But yeah, as you can see, we have the actual sloped footing on our character, and it actually looks really good. It looks awesome. It looks amazing. That's why I wanted to, again, give a huge shout out to Hikari for, you know, telling me about this, because he is right with what he mentioned in the comments. This is almost like killing 3 birds with 1 stone, because you don't have to have the control rig. You get to make you pretty nice little modifications to it if need be. It, you know, does a great job at doing like complex calculations for the foot placement, and it leads nicely into the leg IK. So now to basically show you why I have it in this, you know, order where it's foot placement before leg IK, let me see if it'll do it within here. I tested it out in the game animation sample project first before actually throwing it into here, because I wanted to save this part for the video. But let me see if it'll do it in here so I can show you guys what occurs. So now that we've switched it around and we go into here, yeah, you could see it right there on the left foot, just barely, on how it, even with the right foot now, you could see that it's clipping into the floor. So I'm not quite sure what's going on, but however, I'm pretty sure that with what the leg data is giving us, or the leg IK node data that is being outputted in and being received by our foot placement, is we're getting a bit too much leg data in a sense, to where it kind of messes with our foot placements. So that's why, you know, here it is just better to have the foot placement node ahead of the leg IK in order to like have the proper foot placements and, you know, functionalities. And then when we go back to it now, you'll see the awesome foot placement. So the next thing I wanted to show y'all, and again, another huge shout out for Hikari for, you know, showing me this, is that one of the things that I explained about in the IK video, the leg IK video, but, you know, I didn't think about doing, is that we can actually call this within our, you know, leg IK and our foot placement, right? Or not this specifically, but to get to the fact that we're not in the air, right? That we are on the ground. So, you know, you'll see that we have alpha, and then we have a should do IK trace. Well, the IK trace returns a 0 or 1 anyway, but in the form of like a true or false value, because that's what a Boolean is. So anytime you have like a 0 or a 1, and it's like you greater than this or less than that, you know, it'll give you like a true or false value. However, with the way Hikari did it within one of his blog posts that I was reading to actually do this, you can actually go into foot placement, and I'll also show you how to do it in the leg IK, where right here with the alpha input type, we can just go ahead and, you know, drop it down to float value and then actually do a Boolean value to where we now have enabled disabled. So with that, what we can do now is within this, we can pretty much just hook it up like that, so that way we can call the fact that whether to enable this foot placement or disable it depending on whether we're in the air or on the ground. And then for the leg IK, you can do the same thing here, where if you go down to alpha and you go to alpha input type and switch that to Boolean, then you could do the same thing here. So that way the foot placement and the leg IK fire off, you know, when you are not falling. So if any of y'all have seen my showcase video with the 3Peat Games sliding animation, I've linked his sliding animation video where he goes over like how to set it up and do a tutorial on it, so that way you can actually get it to work. Well, with the way he has it set up, where he's trying to modify the alpha values within the leg IK, instead of doing it the way he did it, where he set up a select node where it was like pick A option, if wants to disable IK, because he set up functionality in the character blueprint to where when you do the sliding action, it disables the leg IK, and then once you're done with it, re-enables it. And then he called that into the animation blueprint, from the character reference here, and then dragged in once to our disable leg IK, and then plugged it into the alpha value for the selection. Well, this is a much easier way of doing it, where you just simply switch, is not falling, and then you just switch these to Boolean values, so that way you can enable and disable them, as you are on the ground or in the air, right? So, because we are using the is falling because we still have that set up, but as we go through and start deleting stuff, so I'm going to delete the control rig now too, is that now what we want to do is, since we have states set up, what we really do want to do is call in our movement mode for the basic form of it and do a not equals enum, this first one right here. And what we want to do is off the not equals is we want to get in air to say like, hey, when we're not in the air, do these things. So now you can plug them up just like that into here. So that way it is being called into both the foot placement and the leg IK. So when we are in the air or doing some sort of thing that is not on the ground, then do this, or at least disable this if we're in the air. So you can get more complex with it. Hikari gave me a little bit of tidbit as far as how to set it up, where you can also do something like getting the character movement component and then grabbing the movement mode off of it and grabbing an is walking, or is moving on ground, and then you do an and boolean to do another movement component to a movement mode, and then not falling, or is falling not. So basically, just to kind of show y'all that, so you can grab off the character reference and go to movement mode, and then off of here you can get is moving on ground, just like that. And then you can also do is falling, just like that. And then you can drag off here to do a not boolean, and I know this is going to be a little bit messy, so let me actually do it like this instead. Let me move that right here, call it right here, and then you can drag up here and do an and boolean, and then you can connect the and boolean into both ways. So this is what I understand from his explanation of what he's trying to do, is where you can basically solidify that these only work when you're operating on the ground. So I'm hoping that I didn't, kind of butcher his explanation, but this is also pretty smart too. It depends on the complexity of what you're looking for or what you're trying to accomplish, as well as, if you want to be simple with it and just get the movement mode enum and do not equals in air. So it's just as long as we're not in air, enable these. So I guess for the moment, what I am going to do is I am probably going to go back, just because it looks a little bit cleaner to do this until I do more tinkering. But I am just going to do a movement mode and do a not equals for the moment, and then not equal in air, and then plug it into both of those, because I do actually want to do some testing and research on utilizing the not in, or the is moving on ground and not in the air. But with that being said, this is pretty much it for the setup. So now we got an actually very fluid leg and foot IK process. And I did have another comment in which to find out how to do dynamic stair climbing, where basically you would climb up one stair at a time, like how you would in GTA 5. And don't worry, piece of Schmidt Games, I am going to research that. I will find out how to do that because I'm just as curious as you are about that. So, but yeah, so, you know, shout out to Hikari again for providing this piece of information for me. I was super excited to want to show you all this. So, other than that, I'm going to go ahead and compile and save. And just to kind of get a better look at it from the game animation sample project, which I do have up. So let me drag it over. So I do have it set, you know, to where it actually looks nicely. I don't have the control rig in here anymore. I have it coming off the offset root bone and set up super nicely within the simple leg IK. But yeah, when you actually play it from here, I don't know why it spawned over there. When we actually go into it and we run up, you can see how nice that footing is, right? It looks simply amazing. It's phenomenal. Thank you, Hikari. I really appreciate it. But other than that, guys, if you did find that video, you know, fun and educational and whatnot, you know, please check out my other videos and my future videos to come. But other than that, y'all have a great rest of your day and take care.